Question number 2 says K solve for values of x or range of x where 2x squared minus 4x minus 3 is bigger than x. So it's a very simple inequality. We just take x on the left side. So we will have 2x squared minus 5x minus 3 bigger than 0. It's so simple. You can split the middle term, break it into factors and then solve it. We solved question number 3 in online class already. We move to question number 4. It has a new condition. It says there is no real value of x for which this mx square plus 8x plus m equal to 6 has any solution. So there is no real value of x that can satisfy this. It means it does not have any real roots. There is no real value of x which can make these two sides balanced. So it's an equation, not an inequality, but in 4.3 we are solving quadratic inequalities. So we just make general equations, general quadratic equations. So we bring 6 on the left side. We have m minus 6 as a c value. We have 8 as our b coefficient and m as our a coefficient. We got a, b, c values. We know the condition that if our equation does not have real roots, that means its discriminant is negative. So we use that condition of negative discriminant. Our discriminant is b square minus 4 times a times c. We substitute all of the values, set it less than 0. So we get minus 4m square plus 24m plus 64 less than 0. If I want to have a positive coefficient, positive leading coefficient, so I divide every term by minus 4. So I divide the first term with negative 4, the second term with negative 4, the third term with negative 4. Again on the right side I have to divide 0 with negative 4. But the key thing to notice is that whenever we divide something with a negative number or multiply something with a negative number, our inequality flips. So this less than sign will change into bigger than sign. Now I have m square minus 6m minus 16 bigger than 0. I solve this is the same thing as solving this one. So we split it, split the middle term, break it into factors. My factors are m plus 2 multiplied by m minus 8 bigger than 0. So if this is my alpha value which is minus 2 and beta value as 8, my results would be m lesser than minus 2 or bigger than 8. This will satisfy my inequality. In question number 5, we have 2x square plus 4x plus 2 equals to p times x plus 3. They say it has two real distinct roots. So we know that the discriminant should be bigger than 0 or b square minus 4ac should be positive. We need to find the value of a, b and c. We need to find these coefficients. So we simplify the whole thing. We multiply p with x, we have px. We multiply p with 3, we have 3p. We bring everything on the left side. So we have 2x square plus 4x plus 2 minus px minus 3p equal to 0. If we merge these terms that have x, we have 4 minus p multiply with x. The rest of the terms are so simple. So 2 is constant, negative 3p is constant. So we have a to be 2 and the b coefficient to be 4 minus p and c coefficient to be 2 minus 3p. We have all these three values. Now we put them in b square minus 4ac term and set them bigger than 0. So we put b value 4 minus p whole squared minus 4 times a is 2, c is 2 minus 3p. We simplify everything and in the end we get p square plus 16 times p bigger than 0. If we take out p as a common, we will be left with p plus 16 bigger than 0. So now I have two roots, first p 0 and the second p to be negative 16. So the smaller root is negative 16. My range of p would be either take p less than negative 16 or take p bigger than 0. You will have the positive values for the expression that we have. Question number 6 has exactly the same thing. It again says that this whole equation has real distinct roots. So the case is similar. You have to use b square minus 4ac bigger than 0. We just need to decide the values of a, b and c coefficients. So something that is multiplied with x square is a. So p plus 2 will be a. something that is multiplied with x term, the coefficient of x is b term, so we have b equal to negative 12, and c is the constant that does not have x, that does not have x square. So we have a, b, c values, substitute them in the inequality b square minus 4ac, and boom, you have your value. In question number 7, we have 2x square plus 4x plus 2 plus m times x plus 2 equal to 0. They say that it has real values. That means it has real solutions. Now it's not given that whether real distinct or real repeated. So for real distinct, we have strictly bigger than 0 discriminant. For real repeated, we have equal to 0 discriminant. So if we just have real values, then it means we will merge both of the cases. We'll use discriminant bigger than or equal to 0. So now I need a, b, c coefficients to plug into this inequality. I simplify it, multiply m with x plus 2, so I have mx plus 2m. We merge the parts that has x in it, so 4x and mx. If I take x common, I will have 4 plus m. The rest of 2m is constant and 2 is constant, so 2 plus 2m stays as a constant. Now my a coefficient is 2, b coefficient is 4 plus m, and c coefficient is 2 plus 2m. We plug those values here and solve the inequality. The rest of the procedure is same. In question number 8, we have 3k x square plus k minus 5 times x equals to 5x square plus 2. Now they say it does not have any real roots. That means the discriminant is less than 0. b square minus 4ac is less than 0. Again, the drill is to find a, b and c coefficients. So we take this on the left side. We have 3k x square plus k minus 5 times x minus 5x square minus 2 equal to 0. This term has x square, this also has x square, so if we merge them, we have 3k minus 5 times x squared. So 3k minus 5 becomes our a coefficient. K minus 5 is multiplied with x, so k minus 5 becomes b, and negative 2 becomes c. We have a, b, c values. We'll plug them in our inequality, and the rest of the procedure is same.